Hello, so we continue with question 1, solving for x. So this kind of equation is a quadratic equation which is an inequality. So what they're asking you to find are the values of x such that the product of these two terms are less than 0. So that's what they're asking you. So they're saying find the values of x such that this term times this term are always less than 0, strictly less than 0. To solve this, let's first make it look familiar. So normally, or the way we like these quadratic equations, is that this x is in this here and this term is on the other side. So that's how we like them. That's how most students that I know like them to look like. So to do this, you just take the negative x, put it in front, plus 1 times x plus 2 less than 0. So this is exactly the same equation that you see here. It's exactly the same equation. So one would want to go further and make it look more familiar by taking this negative sign as a common factor and take it out. So take negative as a common factor. Here you have negative, then you have left with x minus 1 into times x plus 2 less than 0. So negative times 1, x, so it's negative x. Negative times negative 1 is plus 1. So these equations are all equivalent. All these equations, those are equivalent equations. So everyone would like to start here when they are doing this equation. So when you are here, the first thing that you should do is find the critical values. So you know that this equation is the quadratic equation. So the critical values are the points that you can easily locate on this graph. So those would be your x-intercepts in this case. So let's look for those. So find the critical values. So to do this, you know, if you want x-intercepts, this part should all equal to 0, which is this equation should equal to 0. So you have negative x minus 1 times x plus 2 equal to 0. As did with 1.1.1, to get this to equal to 0, this part must be 0 or that part must be 0. Because if this part is 0, whatever the term is, the product will always be 0. Equivalently, if this part is 0, which is the entire part, the entire bracket is 0, whatever this term is, the product of these two, if that one is 0, will always be 0. That's what you want if you want the equation equal to 0. You want at least one of them to be equal to 0. So on that case, you do this. Say, okay, you have this part equal to 0, which is this part equal to 0, or this part equal to 0. So first thing that you can do is divide by a negative sign, divide by negative sign. So we're left with x minus 1, x plus 2 equal to 0. So this part equal to 0, x minus 1 equal to 0, or x plus 2 equal to 0. So to get this to be 0, you would have your x to be 1 here. If you want this part to be 0, the left hand side to be 0, which means this one must be 1. Equivalently, if you want this part to be 0, which means this must be negative 2, so that negative 2 plus 2 will give you 0. So to achieve this, you transpose the 1 to the other side. The 1 was negative, it will be positive there. So we will have x equal to positive 1, or x equal to negative 2. So these are your critical values. So once you have received, you have achieved the critical value, you go back to the original equation. So we said this equation is a quadratic equation, and after we manipulated it, we saw that it's a negative quadratic equation. So this is how a negative quadratic equation looks like. It looks like something like this. So you will have a negative 2 here, you will have a 1 there. So this is how it looks like, your graph. So your negative 2 is here, that is your critical value there, and your 1 is there, that is your critical value there. So they are saying find it where this graph, which is where your graph is negative, less than 0. So it's negative where? Here, which is below the x-axis. Where does this start? This starts when x is greater than 1. Because when x is equal to 1, we know our y is equal to 0. Is equal to 0. So when our x is equal to 1 or x is equal to negative 2, we know y is equal to 0. So we want it where it's negative. So the graph is negative here. It's less than 0 here and less than 0 here. So what are the values? So the values giving, the x values giving these negative y values are these values that are on this side. So that is where x is less than negative 2, or we get the negative y values of the graph. Your graph becomes negative where your x values are below the x's, which is these are your x values that give you these are the x values that give you the negative values of the graph. So that's where the x is greater than 1. So this is your solution for this